Wonderful.
Good.
Kason, you do know that you were in Discord like all night, right?
I was?
Yeah, I don't think you ever left.
Oh. Oh, no, no, no. I was on my computer because I was like messing with it. And then I guess I just forgot to go out of it.
Oh, that's fine. I mean, it doesn't bother me. I just letting you know. I thought about coming
Yeah.
in here and just yelling. You are tired. It's 11:10. How can you be tired still? Bro, I've been
I
teaching for
haven't
2 hours.
slept yet.
You haven't slept yet?
No.
I've done that before. I can't really say anything.
I've been awake for probably like 48 hours now.
That's not good. You know, you start to
But
get
I've had two
delirious.
coffees, so I think I'm fine.
So it's asking you how many college credits you have, Miss Olivia. So how many college credits did you already have coming into this course? Okay, so Miss Madison, or Madeline, sorry, not Madison. You have a question. What number is that? So I can pull it up and see what the actual question is.
Number 13, lesson 21.
21, number 13. Number 13. All right, make sure I have the right problem. A3 is 12 and A10 is negative 1536.
Yes.
Okay. We want to find what? A1 and R. Okay. 12 and negative 1536.
What is today like a review or something?
Yeah, we've covered 20 and 21, and we'll do
Okay.
22 and 23 next week.
All right.
It was A10 is negative 1536. Did I get that right?
Yes.
Okay. So it's going to be the exact same process we looked at yesterday. So we're going to want to write out that A1 is equal to, it's pretty easy, just 12. But then A10 is equal to A1 R to the n minus 1, so I'm going to write a 9. So you get negative 1536 is equal to 12 R to the ninth.
Wait. Um. Why did you put 12 there?
So I asked you if that was right. It's A3, not A.
I can't see the string yet. My computer's still loading, so I don't know what you're writing.
Oh, that's right, like that. A1. So we have, and I'll do that over here then. So A3 is equal to A1 times R squared. So 12 is equal to A1 R squared. So same thing we did yesterday, you just write your two formula, or formulae, involving A1 and R. My, again, suggestion, the easiest way, or in my opinion, the easier way, is to solve both of them for A1. So you get A1 is equal to negative 1536, and A1 is equal to 12 over R squared. What people say. Okay, at that point, we can set those two expressions on the right-hand sides equal to each other because they're both equal to A1. So you get 12 over R squared, 1536 over R to the ninth. So once you have your proportion, which, like I said, all of these problems will work the same way if they give you two of the formulas. It's honestly, it's literally the exact same every single time. The only thing that's different is your R exponents will change. So we get 12 R to the ninth equals negative 1536 R squareds. And then you move this over so you get 12 R to the ninth plus 1536 r squared equals 0. Factor out your r squared, and you get 12. Actually, you can factor out more than that probably. Does 12 go into 1536? I assume it does, to make your life a little easier. 1536 divided by 12. Yes, 128. So r to the 7th plus 128 equals 0. So you get r equals 0 again, which we talked about yesterday. Doesn't make any sense. And then you get r to the 7th equals negative 128. Take the 7th root on your calculator. You should get r equals negative 2.
Okay, I did that, but then instead of doing A1, I tried to do R.
And that does work. You can solve for r, but again, that's why I don't suggest solving for it first, because it creates a much more difficult problem. As I noticed, your ln's and all that kind of stuff, you will have to use, won't necessarily have to use logarithms. If you solve for r, which one did you solve for r in, the squared or the ninth?
I tried to set them equal. I tried to make them both have R squared, which now I realize is incorrect because that means that I had to have R to the 7th on the other side, and you're supposed to have all of them on the same side.
Yeah, solving for r is doable, don't get me wrong. I just don't suggest it. Solving for a1, because it's already by itself, as in it's just a1, is always going to be your easier option there. I would not suggest solving for r first, because it will make your problem a lot easier. And then once you have your r, you can plug it into either one of these two equations you have. I'm always going to use the easier one, which is the 12 over r squared. So a1 will be equal to 12 over negative 2 squared, which is 12 over 4, which is 3. Does that make sense, Madeline?
Yes.
Okay. Yeah, definite suggestion that you're doing these things always, if you're solving for a1 and r like this and these types of problems, a1 first. With those r's having different exponent values, it becomes a much more difficult problem to solve. Okay. Any other questions that anybody has on anything so far?
Can you do 26 on the homework?
Which
21.
section? On 26, yeah.
21.
Ooh, they're trying to trick you on number 26. Yeah. There's a couple of things in there that are pains in the butts. Equals, I think it was 0 to 8. 4, negative 3 to the k. Okay, so this is number 26 on section 21, in case you didn't catch what Madison said. Which bottom? Sorry, Miss Olivia. You're talking about the bottom right? That was factoring. After I set the two sides equal to each other, I factored and solved for r. Okay, so when we're trying to find the sum, obviously in this section we know this is going to be a geometric sequence or series. However, we have to figure out, is this geometric or is this arithmetic or something else entirely? Because on the test we're not going to be told, hey, this is geometric, have fun. They're going to say find the sum. So my suggestion to you is write out the first few terms. So I'm starting at k equals 0, which is different than what we normally have, so you do again have to be careful. So the first term will be 4 times negative 3 to the 0. The next term will be 4 times negative 3 to the first, and then 4, negative 3 to the second. So we got to ask ourselves, in between each successive term, am I adding something? Am I multiplying by something? What am I doing? So sometimes you need to go another step for some people. So you get 4, then this is negative 12. What was that, 36? So at that point, hopefully once you get to here, it's pretty easy to note. You're multiplying by 3 every time. So what that helps us do is helps us figure out that this is geometric. R is equal to negative 3 because it does oscillate. And then we know that our first terms are A1 is equal to 4. So those are all things that we definitely need in order to figure out our summation using our formula. So when we go to enter in everything into our formula, some of it becomes pretty easy. So this will be S sub, well, hold on, I'll be there in a second. So we do A1, so we'll do S sub n is, I'll write the formula up here for the first time. Over 1 minus R.
Wait, why is k equal 0? What does that mean? Like,
That's where you start. What?
I don't, like, normally it's 1. K equals 1.
Oh my god, like they can change things on me? No.
Wait, so like,
How dare they change things
Doesn't,
on me?
I thought that meant, like, it goes up by 1 every time.
It always goes up by 1 every time regardless.
So it doesn't matter.
so
Okay. Okay.
So instead of starting
K
at 1, you start at
equals,
0. So that's all that means.
so
Go ahead, Madeline.
then, so wouldn't a to the 1 equals 4 actually, or a sub 1 actually be a sub 0 equals 4?
No,
Because it's the 0th term?
it is
Because it
not the
starts
0 term. It's still the first term. So this is A1, this is A2, this is A3. It just happens that K and your value do not match up here. But your first term is still your first term. That will never
So-
change. Remember, I told you guys about this. Your I value
Okay.
typically starts at 1. Remember, I did a problem with you where I started K at 2 to throw you off on the notes? Because
Yeah.
that value in your summation could be anything that they want it to be. However, as Brisa asked, this value always increments by 1 each time. So it's 0, 1, 2, 3, 4. I could do a sum from 5 to 12 if I wanted to. So if I want to start K at 5, that means I start at 5 and I go 5, 6, 7, 8, 9, 10, 11, 12 for my K value. These just tell you where you start and end. Remember that. So that tells me K starts at 0, ends at 8. This tells me K starts at 5, ends at 12. That make a little more sense, hopefully? So they don't, as they're trying to trick you, because they will do those kinds of things. Now the question is, let's see, hold on, Miss Libby said something. Whoa. The question is, what is our n value in this problem?
8.
Unfortunately, it is not 8.
What?
How many numbers are there from 0 to 8?
9.
There are 9 numbers.
So n is 9?
N is 9. Again, this is where they're trying to trick you to see if you're paying attention.
I don't get that. Can you explain it?
Count from 0 to 8 and count how many fingers you have up when you're done.
9.
There you go. So when you say there are 8 numbers, you would go 1 to 8. That's 8 numbers. We then have to include the 0 number at the very beginning. If you ever want to get your n, I'll give you a little trick, which is what I was waiting for one of these problems. We call this, when we talk about our starting and ending, I talk about it going from A to B. Your n value will be B minus A plus 1. So in our case, B is 8, K is 0. So 8 minus 0 plus 1 equals 9.
I saw that in the notes and got confused.
Okay.
Like the textbook thing. But now that makes sense to me. Cool.
Yep. The reason for that, the reason we add that plus 1 is you're counting the original number as well. So normally you'd say, oh, from 1 to 9, that's 9 numbers. But 9 minus 1 is 8, so what's the deal? Because you're counting that first number, you got to add that back in. Because you don't start at 1 and go 1. You say, oh, I'm starting at 1 and going to 2. 1 to 2 is 1, 2 to 3 is 3, etc. So you got to be careful on how you're counting and just make sure you count properly. Yes, that is correct, Miss Abby. So there are 9 numbers from 0 to 8 because you include the 0. And then just do that in the calculator. I don't know what that is off the top of my head. It's a relatively large number. Does that make sense now, hopefully, on that problem?
Yes.
That should also help you with the rest of the problems. There are some in that section that start at 0, some that start at 1. I will give you a hint, and you need to be careful as well on things such as if you look at number 24, if you're looking at the book. Number 24, they are trying to trick you on what your a sub 1 value is as well. So be careful for things like that because they could appear on things like the quiz and the test and stuff. So if they have... For instance, things such as a sum from k equals 1 down, let's just do 12 of 0.1, let's just make this a third to the k value. This, most people, what they're going to do is they're going to go, okay, cool, I got this. I don't need to do anything. My sum of 12, because 12 minus 1 plus 1 is 12, is a sub 1, oh, that's 0.1. Oh, my ratio is 1/3 to the n, which is 12 over 1 minus 1/3. I got my sum. I'm done. No problem. I got this. Unfortunately, there is a problem with what's on the board. What is wrong with that?
I know. It's supposed to be 13.
Huh?
No?
No, 12 minus
Right.
1 plus 1 is 12.
Oh.
Because this
Yeah,
one starts at
okay,
1.
what's the point in subtracting 1 then adding 1?
Because
Oh, never
that's...
mind. Never mind. Never mind. I figured it out. Thank you.
Here, okay. No, Miss Olivia, I'm perfectly fine to have a fraction on the bottom. There's no problems with that.
Is it that there's no parentheses around the 1/3 on the top?
No, I don't need them here because it's a positive 1/3. If you want to put them, you're more than welcome to. Don't get me wrong. You only need them if it's a negative, so having them there versus not having them there with a positive number doesn't make any difference. So I tend not to put them, so if you like them there, perfectly fine.
Well, isn't it negative? No, it's not negative. Okay.
Miss Abby is correct. It is the 0.1. That's not my A1. A1
You have to multiply by
is
1/3.
0.1 1/3 to the first, which is whatever
multiply them.
that is. So it's like 0.03 repeating. You have to be careful and remember that our formula, when we looked at our formula, was the summation from like k equals a to b of a1 r to the n minus 1. In our problem, it's not n minus 1, it's just k. Be very careful and do not fall into the trick of looking at that exponent and thinking, oh, it's just that. I got my a1 value, it's right there, boom, done. So we have to be extremely careful. It's only the a1 value if this exponent's the n minus 1, if these all match up, everything, etc., etc. So you do have to be careful, and actually k didn't even have to start at a, k has to start at, and it would be n in this case, my bad. It has to be 1 in this case. If that is not the case, then you cannot use that formula jumping directly into the summation. So you have to be careful and look at what form they give it to you in. For that reason, my suggestion, never take anything at face value. Always check, what is my A1 value? You might want to do a couple of the steps and figure out what is that ratio. Or for the arithmetic sequence, what is the common difference? Make sure you don't fall into a trap of doing the problem too quickly. So hopefully that helps you guys out with not getting caught into any traps that they're going to lay for you, because they will definitely be doing things like that, starting at 0 versus 1, starting at other numbers versus 1, etc., etc. They can do all of those things, and they will do those. I almost guarantee it. to make
I have
sure you're
another
paying attention.
question.
God, what is with you and questions? Like, this is supposed to be me helping you time or something. Calm down. What's your question?
Number 28.
Same section?
Yes.
Okay. So what is your issue on 28?
It ends in infinity.
Oh my god, it ends in infinity?
Yeah. Well, actually, it never ends, but
It means,
like,
so you
yeah,
mean there's
it
like,
goes on forever,
oh,
supposedly.
it's almost like
The-
I should use a formula that has an infinity for a sum in it.
yes.
I got
Can
one
you
of
just
those.
do an example?
I can. All right, so what is our formula for the sum to infinity? And before we say that, before we talk about sum, what is the requirement to use the sum to infinity? That's the important part.
Is it R? Is it about R?
Mm-hmm.
The R is greater than -1, but less than 1.
Okay. So our r basically has to be a fraction smaller than 1. I don't care if it's positive or negative, but the r value itself has to be smaller than 1. It's kind of when I look at it. So what is the r value for number 28? Because you always got to ask yourself, can you do the problem? Sometimes they'll ask you, is it possible, yes or no? So that's always what you got to evaluate. So what is our r value in this problem? Remember, I gave you a hint on how to find your r value with the summation formulas. Anybody remember what that is? So as a reminder, your r value is the thing that has the exponent.
Oh,
Yes, Wasabi.
yes, I
So
remember that now.
our r value here is going to be 2/3. So can I do my sum to infinity with 2/3? And the answer is yes, because 2/3
Yes.
is less than 1. So now, does anybody remember what the formula for the sum to infinity was?
It's the same thing, except for when you have n, you have infinity.
No.
That's what's in my notes.
You didn't finish the whole formula then. So your sum to infinity is a1 over 1 minus r. Remember we talked about the fact that 1 minus r to the infinity goes to, the r to the infinity goes to 0. So it's just 1 on top. So it's just a1. So you might have missed the second half of that equation. So remember that if we had a1, 1 minus r to the n over 1 minus r, if r is a small fraction, and we do r to the infinity, if r is -1 is less than r is less than 1, if we have that, then r to the infinity goes to 0. So we're left with a1, 1 minus 0 over 1 minus r, which is just a1 over 1 minus r. So the sum to infinity. So that's our simplified formula. I'm hoping I wrote that out yesterday, yes. Did I? Because I could have forgotten it. I'm not going to say it, but I thought I did. Everybody else have the form on the board that I have, hopefully. Okay, so if I missed that yesterday then, apparently I don't know if I did or not. I'll take the blame. I'll apologize. So we end up getting that this goes to 0. So the 1 minus 0 turns to 1, so it's just a1 over 1 minus r. So if I left that off, I apologize. So then we just
You
take
probably didn't. You probably wrote it. It's just me, probably.
It's not a big deal. I'll take the blame on that. I tend to forget things, and sometimes it's off on the side and small, so no big deal. So just do your A1. What's our first value on this problem? I don't know. I know it's 1 minus 2/3, though. So what is A1 on this problem? Number 28. So I get 12. So you get 12 over 1/3, which is 36.
That's it?
Yeah, that's it. You just have to
That's
realize
easier
that
than
it's
the other ones.
Yes, the sum to infinity is much easier. The problem is you have to make sure you can do the sum to infinity. Because if you don't do the, if you don't check and make sure, you could still get an answer. For instance, if I go, oh, let's say r is 3. I could do 12 over 1 minus 3 and get that's negative 6 and get my sum's negative 6. That 1 makes no sense because of where everything you put is, but you still get an answer. So if you don't check to make sure it fits the requirements properly, you're going to get an incorrect answer. So they could ask you to do one incorrectly and say find the sum, and they're expecting you to say you can't find the sum to infinity there, and stuff like that. You would tell them, if it asks for an explanation of why you can't do it, you say that r has to be in between -1 and 1 to do a sum to infinity for geometric. You probably could get away with just saying r is greater than 1 or less than -1, whatever it is, and be fine, but I would always go that little extra step and say that r has to be between -1 and 1. That's all. Okay. Any other questions?
I haven't tried this one, but there's a word problem at the end. There's two actually.
Yes,
One
I
of
know.
them is really long.
They're both really easy, though, to be honest.
Okay.
Obviously, it's going to be a geometric series. You're multiplying by something. If you have the book open, if you look at 42, it goes from 0.01 to 0.02 to 0.04. Well, you're multiplying by 2 each time. Okay, cool. And then it's basically asking you, let's see, is it geometric? Obviously, yes. Determine the amount of money you'd receive determine the amount of money you'd receive for working for the month of January. Would you take the deal? Basically, he's saying he'll double your
summation.
So you start off. It is a geometric summation, yeah. So basically, they're saying he'll pay you a penny and then double it every day. So the first day you work, you only get a penny. Second day, you get 2 pennies, 4 pennies, etc. Would you take that deal? And the answer, in case anybody doesn't know, is yes. Yes, take that deal. It's a lot of money. You'll find out when you do the problem. It's a lot of money. It turns into a lot of money very quickly. And then 43, it tells you he's got a salary. He has an increase of 5.5%. So you're looking for your R value there. So yeah, they're pretty straightforward. They're not too bad. All right. So before we end class today, I have one last little trick to show you on the graphing calculator, since nobody's asked yet, which I'm very surprised. All right. A couple of things you can do on your graphing calculator. I'm not going to go over all of them because I don't know how to do all of them. There is a sequence mode, which I've never used before. I'm not going to start using now because I don't really need it for anything, because you can do it in much different ways. However, there is something in here that you have not probably found. If you go to your math button and go up is the easiest way to get to it, there's a summation. I think yours has this as well, Madeline, but it's going to be a lot harder to put in. Sorry. So if you click your summation, it's not even there.
No.
You may want to download this and use it on your computer then.
It's fine. I don't care.
So when you do that, you can put in a summation on your calculator. I always use my x as my variable. You can start at 1, go to 25, and then put in this. So if I want 2x plus 3, I don't know, and then hit enter. It'll give you the sum. So you can check your sums that way. I was very surprised nobody asked if you can use the graphing calculator for this. Yes, Kelvin, you can't do it either on your 83, sorry. But you guys can download the 84 for use on the computer if you want, and you're more than welcome to use that. That's not breaking the rules or anything by using that calculator versus the one in your hand. That's all it does is check your answer. So if you want to check your answers, you're more than welcome to do that. But it doesn't actually, you can't use that as your work. Obviously, you got to do the work and you got to show out things. And show, you'd have to show that this is an arithmetic and then use the arithmetic formula, stuff like that. You can't just write, oh, this equals 725, done. Something else I will caution people on, I don't know if anybody is doing it or not, but I usually see it at least once or twice. Some people are going to write out all 25 terms and then just add them together. Yeah, don't do that either. That will not get you full credit. Things like that. So make sure you're using the arithmetic formulas, the geometric formulas, etc., etc. And you didn't have to, you chose to. Just because you didn't happen to know that I had calculators you could have used. Not. It's irrelevant. Okay. Any other questions about anything? And you did pass. That is true. Any other questions about anything as far as class pertains before I make one last announcement? Okay. Make sure you're doing your homework and ask questions. Otherwise,